All right, we're going to talk about how to graph sine and cosine today with a stretch and compress. So what I have here is I have written down, if you'll write this down at the top sheet of your paper, we're going to wait to do even and odd function when I get back because I'll be able to explain in a little bit more detail. It's hard to explain over a video, but this is pretty straightforward. So what we have is we have what are called parameters. We have these constants A and B. So what we were dealing with when we graphed sine and cosine is we were just graphing y equals sine x and y equals cosine x, which sometimes is referred to as the parent graphs. And remember, we start with sine. Sine starts in the middle, okay? So it starts in the middle, so you might want to write that down. And then cosine starts at the top. Now in pre-calc, you learned some rules for transformations in first try of pre-calc. I'm going to review what A and B do. When you multiply by constants A and B, they either stretch or shrink the graph. So A is a vertical, it's a vertical stretch or shrink, which we call a compress. Okay, so that same thing here, same thing over here. So vertical stretch or compress. When you get to B, I'll do B in a different color here. B is a horizontal stretch or compress. And I can say and or, I guess it doesn't matter. Now let me review what it does, and then I'll tell you in trig what this actually means. So that is what I'm talking about there. Your value B is your horizontal stretch or compress, and A is your vertical stretch or compress. Now, your vertical stretch or compress, when you change it on a trig function, it is related to what's called amplitude, and I will define amplitude for you in a minute. But for right now, just don't worry about it. And then your horizontal stretch or compress is what we call, it's going to be related to the period of the function, which is the shortest amount of, or the shortest interval along the x-axis that it takes to repeat the specific pattern. So we have what's called amplitude and period. Amplitude is going to be related to the vertical stretch, and period is going to be related to the horizontal stretch or compress. So let's talk about A first. If A is bigger than 1, it will vertically stretch. Vertical stretch. And you do need to write all this down. If A is between 0 and 1, it's going to be a vertical compress. Now that's pretty normal. That makes sense. So what I'm saying is if I multiply the sine function, and I'm going to use my little handy dandy mouse pointer here, or laser pointer, which is a lightsaber. So may the force be with you. So sine and cosine, if you multiply sine and cosine by a number bigger than 1, for example, 2, 3, 4, what you're going to do is you're going to change how high the graph goes and how low it goes. So you're going to change the peak and valley. So we know that sine and cosine, it was between -1 and 1. What A will do is it will change that. So instead of it being between -1 and 1, whatever A is, instead of going middle, top, middle, bottom, middle, top, middle, bottom, cosine starts at top and goes top, middle, bottom, middle, top. It's going to change how high up and down it goes. So the amplitude, if I stretch it, vertically stretch it, what's going to happen is if I multiply by 2, for example, okay, it's going to go up to 2 and down to -2. If I multiply by 3, it's going to go up to 3 and down to -3. And if I do a vertical compress, which is a value between 0 and 1, like 1/2 or 1/3, then instead of going up to 1 and down to -1, it would only go up to 1/2 and down to 1/2, or up to 1/3 and down to 1/3. So amplitude, and let's write this down, amplitude is going to be the max and min for the graph. Amplitude, okay, amplitude is the peaks and valleys. And really what amplitude is defined as, it's defined as the amplitude A, how high up and down it goes, is like the radius of the circle. Remember when we were going up to 1 and down to -1, the radius was 1 in the unit circle. But when we do amplitude, it's really the max minus the min, so your peak minus your valley divided by 2, which is going to end up giving you that radius of that unit circle. But we're going to change that radius today. We're going to change it, make it a bigger radius if A is bigger than 1, or we're going to make the radius smaller than 1. And what we're going to do is change how far up and down sine and cosine go. So that is amplitude. The value B is a horizontal stretch or compress. Now B is weird because B actually, if you learned in pre-calc, when it's inside the house, so it's inside the sine and cosine, you're taking the sine of bx, the cosine of bx. If B is greater than 1, or B is a fraction between 0 and 1, here's what's going to happen. It actually horizontally compresses by 1 over B. So it's going to be the reciprocal. And I don't know if you learned this. I don't know. I can't be sure. Oh, I lost it. Let's see if I can get that back. I don't want to have to rewrite that if I don't have to. Apparently I lost it, so I'm going to have to do that again. So if B is greater than 1, it's going to compress, which is the opposite. It's going to horizontal compress. The reason it's horizontal because it's affecting the x. The reason A deals with vertical is it's affecting the whole function, which is really y. Okay, so B is greater than 1, it's a horizontal compress by 1 over B, which is going to be the reciprocal. So there's going to be a reciprocal relationship, and that's because in pre-calc you were supposed to learn inside the house. It always does the opposite of what you think it would do. So when you're multiplying by a number bigger than 1, you would think it would stretch it, but when it's in these parentheses, it actually does the reciprocal. It does the inverse of it. If B is between 0 and 1, which means if it's a fraction, you would think it's going to compress, but it doesn't. It horizontally stretches because you're going to take that reciprocal of that fraction. Because again, it's going to be the reciprocal of B. So if you have 1/2, it actually stretches it by 2. If you have 1/3, it actually stretches it by 3. What's going to happen when you have this horizontal stretch or shrink? It's going to change the period of the function. Now, we already know the period for sine and cosine is 2 pi. But what's going to happen is that period is going to get divided by B because of this stretch and compress. So we're going to take 2 pi and we're going to divide it by B. So the period's going to be a little weird. Amplitude's going to be pretty straightforward because the amplitude is just going to be whatever A is. So when we do amplitude, it's just going to be the value of amplitude will just be whatever A is. That'll just tell you what that new radius is and how far it's going to go up and down from the middle, because that's what it's really doing. It's measuring max minus min divided by 2, which is how far you are from the middle. It's how far up and down you are from the middle, which basically is the radius of the unit circle. But we're going to change that radius so that it's not 1 today. So we have amplitude is going to be the value of A and period is going to be the value of B. There's one more thing that I got to talk about, and that's when there's a negative A and a negative B. So if you make A negative, if A is negative, and I will deal a little bit more with B being negative tomorrow. If A is negative, it's going to flip over X. It's going to flip over the X-axis, and you would have learned that. Those are called your reflections. So if the value of A is negative, it's going to flip it over the X-axis. So what's going to happen in your sine graph, it's still going to start in the middle. But what's going to happen, instead of going middle, top, middle, bottom, it's going to go middle, bottom, middle, top. So it's going to flip. Instead of sine going up from the middle, it's going to go down from the middle. Cosine, what's going to happen if you flip it, instead of starting at the top, it's going to start at the bottom. Now B is negative. If B is negative, it's not, and we're not going to really deal with this because I'm going to change it. It technically flips over the Y, but I'm going to hold off on this one because there's a way to deal with it with even and odd function rules that we can just eliminate the negative b and actually either drop it or take it and pull it out front. And I'm going to show you that tomorrow. So don't worry about this one yet. Just wait, because when I show you even and odd functions, it'll make sense. But we will deal with a negative a for sure. Okay, we will definitely deal with a negative a. So let's take a look at some examples. I'm going to do 3 examples with you, and then I'm going to give you your assignment. So they're pretty straightforward. So I'm going to have y equals 2 sine 3x. So here's what we have. We have this y equals a sine bx. All right. So a is the amplitude. So I'm going to put down a. A is equal to 2 because that's right here. Okay. So that's my amplitude. That's going to be how far up and down I go from the middle. So I'm going to go up 2 and down 2 instead of up 1, down 1. B, which I'm going to do in blue, I'll continue to use blue, is related to your period. But what it does, remember we said it horizontally stretches or compresses by the reciprocal. So it seems like it would stretch it by 3, but it actually shrinks it by, or compresses it by 1/3, because you got to do the reciprocal. Now we know the period for sine and cosine was 2 pi. So we got to take 2 pi divided by b. So you're going to need this little formula, 2 pi divided by b. But if you learn the rule, you don't need to memorize the formula. You just know how it works. So here's how we do this. I'm going to give you very specific steps on how to graph this. Step 1, and this is how I always do it. Step 1, okay? You're going to plot 2 periods. Now the period has changed today. So I'm going to teach you the same way. We're still going to do our quarter rule. Quarter rule. We're going to divide it up into 4s, cut it in half, and do all that stuff. So our quarter rule is when we set up, so we're going to plot 2 periods. Now we were always doing it to 2 pi, okay? So this app I'm using, I can't do my straight line tools like I did before, so they're going to look a little wobbly, but I think it'll still work. I probably have a line tool. Let me just investigate here. Let's see if I have a line tool. I bet I do. Okay, let me pause this. Okay, I did have a line tool, so that worked out. So I was able to find one. It probably was instant for you guys, which is good. So what we're going to do is we went all the way up to 2 pi. But now the period has changed. We're not going to go out to 2 pi. We're going to go to 2 pi over 3. We're still going to do our half marks. And over here, we'll do negative 2 pi over 3. Do our half mark. What's half of 2 pi over 3? Like you have to literally cut 2 pi over 3 in half. Half of 2 pi over 3 would be pi over 3. So this would be negative pi over 3 over here. Then you're going to go half of pi over 3. Well, half of pi, think about it, half of pi over 3, I'll write this down for you over here to the right, is just pi over 6. You're just going to keep multiplying the denominator by 2. Sometimes it reduces, sometimes it doesn't. Like when you took 2 pi over 3, you took half of 2 pi over 3. It's pretty obvious the 2's are going to cancel, and that left with pi over 3. That makes sense. Half of 2 pi over 3 is pi over 3. So that's pi over 6 when you do half of 2 pi over 3. Now this is your count. Remember, this right here is the most important one. Okay? So that's the one you count by. So when you go to your 3/4 mark, what you're going to do is you're going to say, okay, I'll get my trusty little lightsaber. 1 pi over 6, 2 pi over 6, 3 pi over 6. 3 pi over 6 reduces to pi over 2. So we can now put that's pi over 2. So now I can come over here and negate it. Negative pi over 6, negative pi over 2. All right. So now we've done step 1. Step 1, plot the period. Step 2. Now, I will add some steps. There will eventually be 4 steps when we do phase shift and vertical shift tomorrow. But for right now, we're just going to have 2 steps. Step 2, use amplitude. Use amplitude, use amp. I'm just going to put amp, but it means amplitude, to plot pattern. Now, we know the pattern for sine and cosine. Not pattern. Okay, to plot our pattern. So here's what we know. Sine starts in the middle. So we're going to put sine in the middle. But our amplitude is 2, so I'm going to go up 2 and down 2 from the middle. Because the amplitude, remember, is max minus min divided by 2. The max is 2, The min is -2, and if I take 2 minus a -2, 2 minus a -2 would really be 2 plus 2, which is 4. And then half of that is 2, and that's what that little formula was up there. If you recall, I had a formula up there. Let's see here. Sorry, I'm doing some goofy stuff right now. Let's see if I can actually, I don't want to move that. Oh, there we go. Come on, stop doing that. I can't get to the top of the screen. Can I scroll? Let's see here. Don't worry about it. You can see it up there. It's up there. Max minus min divided by 2. But anyways, so what we've got is we got sine starts in the middle. We have an amplitude of 2, so it's going to go up 2 and down 2. There's no negative, so it's going to be normal. So it's going to go middle, top at pi over 6, middle at pi over 3, bottom at pi over 2, and middle at 2 pi over 3. So it's the same pattern we were doing before. Top, middle, bottom, middle. Now if I go in reverse, it's going to be middle, bottom, middle, top, middle, bottom. So then it goes to the bottom, middle, top, middle. And now we sketch our graph. And then you can draw sine graph now. So I'm going to sketch my sine graph out, and then the last thing you're going to do is tell me what the domain and range is. So the domain would be double bar R, because it goes forever. It's going to keep going. If I went out further, if I went to a 5th mark here, I count by pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This would be 5 pi over 6. And it would keep going, and that would be up at 2. So I could keep graphing sine. So I know this thing's going to go on forever. And now the range, it's not between -1 and 1 like normal on the unit circle, because I changed that circle and basically I dilated it out to a radius of 2. So it's -2 to 2. So there's my domain and range. So there's your first trig graph with transformations done to it, with vertical stretches and shrinks and horizontal stretch and shrink. Now what I want you to know is the vertical stretch and shrink affects its amplitude, okay, directly, either by stretching it by 2 or shrinking it by, like if I threw a 1/2 out front, it would shrink it by 1/2. But the horizontal stretch and compress stretches and shrinks by the reciprocal. So that's why you have to divide by that 3. Okay? So now we're going to do another one. So let's go to another problem. I'm going to do 2 more. Let's do a cosine one. And then I'll end with something a little bit different. So here we go. So let me get my pencil. Let's go -3. Let me shrink my pencil up here. I don't know why it's if we zoom out a little bit, it'll probably be better. Let's do that. Okay. Y equals -3 cosine. Let's make it a little more complicated. 5x. Okay. There is a negative this time, so that's going to flip the graph. So instead of cosine starting at the top, it's going to start at the bottom. This cosine usually starts at the top. So I'm going to make that note so I don't forget to do that. Amplitude, my amp is going to be 3. My period, it's going to shrink by the reciprocal. So instead of it, the period for cosine is 2 pi, but it's shrinking. And here's why, because this number is bigger than 1, it's always the reciprocal, so you divide by 5. Remember, period is 2 pi divided by b. You got to remember to divide by that b. So, step 1. Let's go back up to the steps. Step 1, you plotted 2 periods using your quarter rule, your 4th rule. So you make your 4 marks on both sides, and then use the amp to plot pattern. So here we go. Let me zoom back out. Let's see here. Let's draw a nice pretty graph. Let me get my line tool again going. Oh, okay, got my line tool, so I'm going to go out 1 period. Let me put let's do this real quick. Let me put my arrows here at the end. Not that that's a big deal. So I'm going to go out to 2 pi over 5. I'm going to go half of that. Half of 2 pi over 5. Think about it. If you've got to write it down, that's fine. Half of 2 pi over 5. The 2's cancel, and we end up with pi over 5. So we're going pi over 5. Okay, half of that, if you got to write it, it's just going to multiply the denominator by 2 if it doesn't reduce. So it's going to be pi over 10. That's going to be my count. So I'm counting by pi over 10s. So my 3/4 mark, I know we've never done this before, but I know you can handle it because I've taught you how to count by pi over 6s, pi over 4s, and pi over 3s. 1 pi over 2, 1 pi over 10. Let's do it right. 1 pi over 10. This is my count right here. 1 pi over 10, 2 pi over 10, 3 pi over 10. Okay, 3 pi over 10. And if you go out all the way, you go to 4 pi over 10. And 4 pi over 10 does reduce to 2 pi over 5. So we know we did it right. I'll do it again. 1 pi over 10, 2 pi over 10 reduces to pi over 5. 3 pi over 10, 4 pi over 10 reduces to 2 pi over 5. If you went to 5 pi over 10, it'd be interesting. It would actually get you to, if I did one more mark, let's just do it just for kicks and giggles. If I did one more mark, you would get pi over 2. So you're not even, like, you've really shrunk. You've shrunk the period 2 pi by a fifth. So if you shrunk it by a fifth, you would actually complete 5 cycles in 2 pi radians. So you would get 5 of the cosine graphs done in 2 pi radians if you went all the way out to 2 pi. You know, we're not going to do that. We're just going to go out to 2 pi over 5. Now you negate it. So you got negative pi over 10, negative pi over 5. It's easy to do the other side, negative 3 pi over 10, because you just copy it and make them negative. And then negative 2 pi over 5. Now, cosine starts at the bottom this time, and the amplitude is 3. So I'm going to go down 3, started at the bottom. And I'm also going to end up going up 3 from the middle. So the middle is still the middle. So bottom, middle, top, middle, bottom. And if I went to the next one, it would be in the middle again, but I'm not, you don't have to do this one. Okay, so then it goes middle, top, middle, bottom. And then you remember, when you draw cosine, I always say draw it kind of like it's a roller coaster, because you're starting from the peak or the valley. So you got to come off that top like it's a roller coaster. If you want to start at another point, you can. I mean, you don't have to draw from the top or bottom. You can draw from the middle. Some kids like doing that a little bit better. Okay, and this thing will continue on forever, so the domain will be double bar R. And the range, it'll go down to negative 3 and up to 3. Okay? If you want to stop the video at this point and try one, I'm going to write one down for you. So let's do one more. So let's do another sine one. Let's go y equals negative 1/4 sine of, let's actually make it, we haven't done, let's do something weird, 2/3 x. So if you want to try this, you can. If you want to stop the video at this point and try it. Okay, I don't know if you took me up on that. We'll see. But anyways, I'm gonna go ahead and draw my x and y axis. So let me do that for you. All right, I got my x and y axis. First of all, we have a negative, so it is sine still starts in the middle, but go down first. You're gonna go down first instead of up. So we're gonna go down first. Amplitude, this time is 1/4. So you're only gonna go up a fourth. So some people are like, well, how do I show a fourth? You can just, if you just do this, go up 1 and put that it's a fourth. That's good enough for me, because you don't have to make it so you don't want to go up, what am I trying to say? You don't want to go up just a little bit, because your graph will be really squished. So you want to go up a decent amount so you can graph it and you have room to graph. So just label it that, oh, I went up a fourth and down a fourth. You're kind of zoomed in on it, if you will. Period is going to be 2 pi divided by b, remember? Now this is weird because this b is a fraction. So we know it's 2/3. And if I do the reciprocal of that, it's 3/2. So it's going to stretch it by 1.5 or 3/2. But how do you do that? Well, you take 2 pi divided by b, which is 2/3. So what happens is you end up multiplying by the actual reciprocal. So 3/2. So there it is, the 1.5. So the 2's will cancel. You see that? The 2's will actually cancel. And your period is actually 3 pi. So the 2's cancel. So my period is going to be 3 pi. So I'm going to go out to 3 pi. I'm going to do the halfway point is 3 pi over 2. I'm going to do half of that. Now this gets weird. Half of 3 pi was easy, 3 pi over 2. Half of that is going to be 3 pi over 4. Just multiply the denominator by 2. Think about it. Half of 3 pi over 2, right here. If you multiply that denominator by 2, you get 3 pi over 4, because you're just multiplying by half of it. My count is really weird. It's 3 pi over 4. So watch when I count this. You're going to have 1 3 pi over 4. You're going to have 2 3 pi over 4. 2 3 pi over 4. Let me actually write that down. 2 3 pi over 4, because your count is 3 pi over 4. Then that 2 would go into 4 twice, and so it does end up being 3 pi over 2. So that's how that works. So we're going to be, let me put my third mark in here. We're going to be 1 3 pi over 4. I hope I said that right. 1 3 pi over 4, 2 3 pi over 4, 3 3 pi over 4. I hope I said that right the first time. I don't know if I did now. 1 3 pi over 4, 2 3 pi over 4, 3 3 pi over 4. So what will 3 3 pi over 4 be? 3 3 pi over 4, and this one would be 4 3 pi over 4. And look, the 4's just cancel, and that's how you end up with that 3 pi there. So we know it works. This one's going to end up being 9 pi over 4. So let me erase all that stuff. So 3 3 pi over 4 is going to be 9 pi over 4. So let me do that one more time. So what I did is I went out to 3 pi. Okay, so I don't want to lose anybody. I do my period. My period's 3 pi. I do half of it's 3 pi over 2. I do half of that is 3 pi over 4. So then my count is 3 pi over 4. 1 3 pi over 4, 2 3 pi over 4, 3 3 pi over 4. And the 3 times 3 is 9. This would be 4 3 pi over 4, and the 4's would cancel, and you end up with 3 pi. So now I just negate it. Let me go a little further than that. Let's make it a little realistic. 2, 3, 4. So we got negative 3 pi over 4. We got negative 3 pi over 2. We got negative 9 pi over 4. And we got negative 3 pi. So if you notice, this was 2/3. This was smaller than 1. It actually stretches the period out past 2 pi. So now we're actually completing a cycle of sine further than 2 pi because it's stretching it horizontally. Sine starts in the middle. It's going to go to the bottom first, go down first. So bottom, middle, top, middle. Okay? Top, middle, bottom, middle. So now I graph it. And there's my sine graph. My domain will be double bar R. My range will be from negative 1/4 to 1/4. All right, so what I'm going to have you do tonight for homework, I'm going to have you, for a lot of problems, I'm just going to have you write down what the amplitude and period is for I think it's 18 problems or 20 problems where you're just going to, all you have to do on that page 76 and 77 is you're just going to write down the amplitude and period. Then there's going to be 8 problems that you actually have to graph. So you're going to graph 8 problems, and what you're going to do is exactly like we did in these 3 examples where you plot out 2 periods, you find the amplitude, the period, you plot 2 periods, and then you plot out your pattern using your amplitude. So that's your homework tonight.